In this example, we have Mr. Jack standing on the Earth's surface, and we're looking for the force of gravity between him and the Earth. And we got a bunch of stuff given here. So imagine here's the Earth, and I'll try to put the center, I don't know, maybe here somewhere, something like that. And this is obviously a big exaggeration. I know Mr. Jack is tall, but he's not this tall. Here's Mr. Jack. He's on the surface of the Earth, and the radius, well, the distance between Mr. Jack's center and the center of the planet is really just the radius of the Earth. Okay, and you might say, well, wait a sec, what about this little, bit of distance in here? What about Mr. Jack's height? The radius of the Earth is this. It's huge, right? It's over 6 million meters. Mr. Jack's extra half a meter to his center is not going to, or extra meter maybe to his center is not going to make any difference in our calculation. Okay, so when we talk about distance, the equation that we're using here on this thing is Fg equals g m1 m2 over d squared. The d that we're using here is really just the radius of the Earth. As long as you're on the surface of a planet or something, we're just using the planet's radius. Okay, so we're looking for Fg, the force of gravity. So we've got to know this mass right here. That m, I'm going to call it, well, actually, let's call it one m2. Doesn't really matter, but let's call this one m2. We'll call mass of the Earth m1. Okay, so right here, me, we're going to treat this as m1. Okay, so I don't know if I can stick a little 1 somewhere, but radius of the Earth, that's going to be our d. So when we go ahead and sub these numbers in, I'm going to give myself some room here and say Fg. Remember, capital G, this is on your equation sheet. You don't need to memorize this number, but a lot of you will just from using it. That's big G. That's always true. Okay, big G, 6.67 times 10 to the negative 11. Mass 1, we'll use that as the Earth's. Again, it doesn't really matter. You can multiply in any order. The other mass is Mr. Jack's mass, right? That's our 70 kilograms. Do make sure that the masses are in kilograms here. D, that's just going to be the radius of the Earth. So 6.38 times 10 to the 6. And don't forget to square it. Sometimes when we put that 6 as an exponent, then we forget that there's also a squared outside of that bracket. And I'll encourage you to use your exponential button on your calculator. So 6.67, the exponential button is either like EE. So when I type it on my calculator, I'm typing 6.67. And then exponential button, sometimes it's EE. I have seen it as EXP. The one on my calculator right here is actually times 10 to the x, something like that. Okay, so whatever that button is, your exponential button. 6.67 exponential, and then negative 11. And again, your negative sign might be the plus minus or negative and sign in brackets or something like that. Okay, so when you type that thing in, then you can just say times 5.98 exponential 24 times 70. That should give you the whole top. You can hit equals there if you want. And then divided by 6.38 exponential 6, and then squared, and then hit equals. And you should get 685.9361641, something like that. And then for sig digs, we would say it looks like 3 sig digs. So the force of gravity acting on Mr. Jack, 686 newtons. Force is measured in newtons. This is a force. You could say, shouldn't I have direction on here? Sure, you could. You could say the direction is down. But typically when we're doing force of gravity, it is always down, right? It's always towards the center of the planet that we're on. So that's kind of understood to be true. So typically, like they do in the answer here, or like I did, I guess, just magnitude only is fine for force of gravity. But if in doubt, put the direction if you're unsure.